Just getting all my social media stuff done. I don't like to post. I don't like to post and then go live. I don't know why. I just like to go live and then post. It's just... And I like to smack my microphone too, apparently. I don't know what it is. It's just weird to me. It's weird to me to like not be live, post about being live, then go live. I just prefer to go live and then tell people that I'm live. If they give a crud, they'll come check it out. So we're gonna shoot these out. That's what we're gonna do. God, that's gonna get me every flipping time. Flip. Drives me completely bonkers. Because, and it's my fault as I switch from Pop OS to, well, I switch from MacBook. MacBook's my day job. I've said this a million times, but it gets me every, that control versus command. It just gets me every stinking time. Alright, already told the Discords, which again, I haven't pushed my Discord publicly on, in all honesty. Let's tell the X. I wonder if we should actually post this. I created a Facebook page today. Should I post this on Bookface? Let's do it. Let's do it. Let's go. My desk is so wobbly. That's what I get for being in standing mode. Yeah, we'll go, let's go to our page. No one's followed this page, but we'll still post to it like some sort of psycho. Fewer than 10,000 posts. Okay. I don't know why I'm doing this to myself. I don't know why I'm posting on Bookface. No one cares. Okay. Yep. And YouTube is happy with me. Twitch is happy with me. And I just mean general quality. Gosh, I'm thirsty. I thirst for water. Okay. There we go. All that stuff is done. I'm a real boy. We'll put the OBS right here where I can see it. Because we all know we're streamers. We want to stare at our own face. Today, what I wanted to talk about is this video from Dave Farley from Continuous Delivery about don't do end-to-end testing. That's offensive because that's my job. Dave? That's literally my job, Dave. Dave, listen to me. Dave. This was published a year ago. I have a very vague recollection of this. So hopefully my response or reaction is sincere enough or interesting enough, because I don't remember. I remember that it's a good video. The title itself tells me that I should be upset by the video. But I have a feeling most of the time with Dave's content on this channel, it's always really balanced. It's always really good advice. Though, as I've mentioned before, we watched another one of the videos from his channel. It tends to skew towards the software developer, not really advocating to software testers. But here, this particular one, it'll be interesting to see what he has to say. I don't remember, it's from over a year ago, because that's my job. My job is to mostly do end-to-end testing, do some things in isolation. Most, I think, SDETs, QA engineers, we're focused on end-to-end testing. So we're gonna see what Dave has to say. It's a 17-minute video. I highly suggest going to his channel, subscribing, finding some great videos to view and to like, and all that kind of jazz. Yeah, let's let Dave tell us why we should stop. Basically, why I shouldn't have a job anymore. Tell me, Dave. Tell me. What am I supposed to... And then, Dave, what am I supposed to do with my life after? If I don't have a job and no one's doing end-to-end testing, what am I supposed to do? What am I supposed to do, Dave? I guess we'll find out.
End-to-end testing sounds like a great idea.
Oh yeah, I want to turn my music off. What a fool. Let's roll that back. Can't see around my camera stand. It blocks part of my monitor. Just silly things like that. Okay. Take two. Take two. Tell us, Dave. Why should we stop doing end-to-end testing?
End-to-end testing sounds like a great idea, but it's really not. The problem is that for anything other than simple systems, end-to-end tests can be big, complex, fragile, and don't really control the variables enough to allow you to take proper control of your system under test, and so properly test it or understand the results. On the other hand, thoroughly testing your system in production-like test environments and in life-like scenarios is a great idea. So how are these two ideas different, and how do we achieve the good one while avoiding the traps of the bad one? Oh, and it probably depends on what you mean by end.
Okay. I think I remember this now and I see where he's going. I have a couple of thoughts about this, but I don't want to bury the lead either. So I'm going to let him keep going, actually. I'm going to let him keep going because I have thoughts. I have thoughts about what he just said. Because there's a lot there to pull apart about, what do you mean by end-to-end testing? Because I kind of agree, and maybe I falsely depicted what most testers do, because actually we don't technically just do end-to-end testing. If you're doing it right, you're doing a lot of testing in isolation. You're breaking the app into parts, whether it's the service layer, the components, or the UI, and hopefully isolating as much as possible to get the most stable test. But there are times you need to do end-to-end. You need to validate a flow. Granted, there is that theory you could break all the parts up and test them independently that are part of a larger flow. There's still a chance that something could go wrong, especially if you're mocking things. You're mocking like a service you don't control. But we'll let him keep going here because I have thoughts already off of this, but I don't want to bury the lead in case I think he's going where he's going.
Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. And if you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. I'd like to begin, as ever, by thanking our sponsors, Equal Experts, Octopus, Tricentis and Transfic. They support this channel immensely, so please do support them in turn by checking out their links in the description below.
Must be nice. Must be nice to have sponsors. Oh man. It'd be nice, but we're just starting out. Right? Gotta be realistic.
This episode explores one idea that we explore in a lot more depth in my new training course, Acceptance Test-Driven Development and Behavior-Driven Development, Stories to Executable Specifications.
Oh man, he's bringing up BDD. Maybe I need to take that course. I just don't believe in BDD. I'm sorry. I have yet to be... Well, I think if I remember, Dave's a big proponent of SpecFlow, and I'm pretty sure SpecFlow is the Microsoft BDD product. And I have yet to see BDD work well back to front, and I've yet to see it scale well. Maybe it's an implementation or skill issue. I'm not sure. But I'm always skeptical when people bring up BDD. I just have yet to see it work. But Dave's the expert. Obviously, people look to him for, best practices, for SOP and process. So we're going to let him talk about his course.
This course is on sale in pre-order now, so this is a great time to buy it at a big discount. There's a link in the description below. What most organisations mean when they talk about end-to-end testing is testing the whole system in some environment that is a mirror of production. This is a good idea. We want to be able to test the deployment of our system in a lifelike setting, checking things like its configuration and any infrastructure changes that might affect its behaviour, as well as validating that the new features that we've added actually work and reassuring ourselves that we haven't broken anything that was working before. The trouble is, how do we do that? The most common version of end-to-end testing that I've seen in practice is to create something that's often called a staging environment. The idea of this, particularly in teams building big software, is to maintain a kind of shadow copy of the production system. A team works on some changes for their system, and then as part of the release process, they're required to deploy the new versions to the staging environment before release, where they will be evaluated, usually with manual testing, alongside every other team's new versions to check that everything works together.
Not always manual testing. If you're doing this well, you have an automated build acceptance suite that's going to accept that build. And it doesn't have to be unit testing. It doesn't have to just be component testing with lots of mocking. I don't know. I hope he's not building a straw man. I do love the graphics though it's almost turning into pentagram. Looks like, oh man, we're getting into the occult. But I hope he's not building a straw man. And to be fair too, Dave's going to have a lot more experience in the industry than me, though of a different era. I don't know if I'm like 2 generations behind Dave or just 1 generation behind him. It's hard to say. But it could be setting up a straw man here where I've seen a lot of places, even if they're not great automated tests, that they have some sort of suite they're going to run that's automated in something. Selenium WebDriver, especially end-to-end, they're going to go through the UI. Or if it's all microservices and someone else builds the UI or has no UI, they're going to have something. Postman tests using the Newman CLI, something. Frisbee.js, Rest Assured, Rest Sharp, something to test those microservices actually deployed, actually integrated.
Often, all of this is carried out by people in teams that had nothing to do with the creation of the software. The ops people deploying the changes probably haven't seen them before. In seriously dysfunctional teams, they may not even know what the changes do. Testers in places that test this way are usually paranoid, and with some good reasons. So,
how dare you say that, Dave? Though he did say for good reasons. I take personal offense to that. Joking.
They test everything. This is slow, expensive, and doesn't give a very high quality result. The testing has happened too late to help build quality into the product.
I agree with that. Okay, I agree. I think maybe our definition of end-to-end testing wasn't aligned at the beginning. That's where I got initially skeptical, but I agree with that. That is, you are not shifted left enough. You're too late in the process. You're essentially operating as waterfall or Kanban, but only your testers and maybe your deployment people. I would agree with this.
It's just used as a gatekeeping process to hopefully catch the biggest mistakes. The testers have good cause to be nervous, as I said, because the chances of something going wrong at this point are really quite high. If this is the first time that the pieces of the much larger whole are brought together, it's highly unlikely that everything's going to work seamlessly. However diligent the planning, the ways in which software and the people who build it can screw up are many and varied. In organisations that work like this, they're almost inevitably working very slowly. So the gap between each release and so each end-to-end integration test is usually weeks or months.
Yeah, most teams, I've kind of mentioned this before, most teams actually operate, at least from a testing standpoint, more waterfall or Kanban. Just the cycle may not be the same, where in the typical waterfall or Kanban, the dev team, being just the developers, a lot of times goes dark. Then they finally release something. Now QA, maybe DevOps gets their hands on it. Where in the case of Scrum, the dev team is in the sense of that the developers are operating Scrum, but the testers are running mini waterfall, mini Kanban sessions. They're not thinking about testing most of the time until after it's deployed. Again, I would agree with Dave here. There are methods I've talked about in the past, but I don't want to bury, in case he goes where my brain's going, the solution for this, I don't want to bury that lead.
That means that the amount of change going into each release is huge, which means in turn that the chance of something being wrong increases. And the costs of finding it and correcting it when something does go wrong goes up exponentially with the number of changes too. There's another problem. If we are working on a system like this, and we are working on Team B, the kind of system that is downstream from System A and upstream from System B, and this is the only way that we test, then we can't test System B properly at all. If we want to do a good job of System B, then we'd like to test it when it's facing difficulties, as well as when everything's working smoothly. We may like to see, for example, what happens if System A sends our system garbage. But we can't do that if there's a real System A in place. It's
not if you can if you use Cypress or Playwright. You can intercept those calls in the actually deployed system and see what happens when they fail. How does that component respond? How does the system respond? You can mock some of this out. So I disagree. Can SpecFlow do that? I don't know, honestly. I'm assuming SpecFlow has to have some mocking, spying, stubbing capabilities. But Cypress will allow you to do this. You could fail the calls from System A on purpose. In fact, you could also always have the best calls from System A for a particular test where that call is sort of inconsequential to what you're actually testing. Where, for example, you have a cart, a e-commerce system, you could always mock the best cart in that instance because maybe you're just wanting to make sure that a component responds to that cart properly, a known cart, for example.
It's not sending us garbage. We'd probably be interested to know how our system copes when it can't establish a connection to System C or loses that connection. But if the connection is working fine, we can't test this either. These are symptoms of a deeper, more fundamental problem. The bigger and more complex the system, the less thoroughly we can test it because we've lost control of the variables. System A and System C are changing, and we don't know how. And because this big end-to-end thing is so complex, anything that we do is at arm's length. I once joked that this was a bit like eating spaghetti through a letterbox with chopsticks. We really don't have much visibility or much control. If we're primarily interested in testing our system, System B, then we need to do a lot better than this. The key idea here is test isolation. A good test is deterministic and atomic. It's going to put our system under test into a precise, predictable state, the state that we need it to be in order to run our test.
Literally just said that, right? In the sense that you can mock and stub the other calls from the other system, even with a deployed app like System B, with the right kind of tools. So I agree. And I agree with atomic tests. I'm personally a big proponent of very atomic, isolated tests within reason. You always got to look at the situation and make sure it makes sense. But, I know where he's going, I still think there's value to those bigger end-to-end tests for really important flows, really important user interactions and personas and users of the system. There's sometimes things you won't find that go wrong that you can only find when you do that full flow, even if you isolate each piece. Maybe those tests are always manual. Maybe they're only run during just before a release. Or maybe they are automated. But, because I see where he's going, I am a proponent of isolated, logical broken chunks. But I'm also still a proponent we could go back to the testing pyramid and talk about this. We could. That might get a little too off on a rabbit trail. But you still want, at the top of that pyramid, you've still got the little cloud, and the one that we looked at the other day. You got a little cloud that's like your exploratory testing. And then you still have that piece of those end-to-end tests that are valuable. They are a smaller subset than these type of tests that he's referring to, but I still think they're necessary, in my opinion. There's just too much risk. Again, you could take general terms or general approaches like this, but you have to be careful when it comes to regulation, when it comes to specific usability. There may be things you have to cover based on compliance, and you have to make sure those things are tested. They can't be tested in isolation. You have to test them end to end because of compliance. There's just times you can't get away from this. But I agree. I think what he's trying to get away from is the anti-pattern, the ice cream cone anti-pattern, and get more towards the testing pyramid. But I think he would lop the top of the pyramid off if he could. I really think he could. I think he just literally cut the top off.
And every time that we run this test for the same version of the software, whatever the circumstances, whatever the time of day, whatever else is going on in the system at the same time, we want the same result every time. To maintain the stability of our test, we'd also like it to do that without relying on anything else outside our test and the system that it's testing. We want our test to be targeted and specific. Actually, more formally, I recommend that tests should be concise, accurate, understandable, and durable. They need to be concise so that they aren't too much work to create and clearly focused on a single outcome. They need to be accurate so that they can clearly specify what the system ought to do. They need to be understandable so that we can use them to help everyone associated with the development of the system to understand what the system needs to do, and that this test, if it passes, says that it does it. And they need to be durable, meaning that these tests aren't easily broken by changes to the system.
Yeah, I would agree. Let's go back a little bit. I agree with all of those. I agree with all of that. So obviously you get to deterministic. Well, he already talked about deterministic. So we already talked about atomic and deterministic. We'll get to concise. I agree. Tests should have one purpose. Following the arrange, act, assert model will help you with a lot of these, regardless whether you're writing unit tests or higher level integration tests. Is you're going to arrange your test, get it ready to do something. You're going to act, and then you're going to assert. The durability, that is a little bit tougher, though. Again, following like the atomic model will help you be durable. Tests wear out. This is something that is just a bitter pill you kind of have to swallow when you're trying to do software testing. Is you have to realize your tests are going to wear out. The more you run them, and the more the system kind of diverges from that functionality, the less relevant they're going to become, and you're going to have to update them. It's just going to happen. I understand what he's saying. Like, it should be harder to break these tests. They should be, and again, using tools like Cypress, using tools like Playwright, it's a lot easier to make more durable tests that you can say, wait on a particular call that happens before the test proceeds. So now you're hooked into app state. Getting hooked into app state is huge. And it's harder to do using the more antiquated WebDriver the WebDriver implementation. And instead using the DevTools protocol type tools, it's gonna be a lot easier to hook into that app state and get a lot of these things that he's talking about here. Because when you're hooked into app state, again, you know what the state the app is in, what it's most recently done, and you could be patient without having to do things like system, without having to do thread sleeps, which are always hard waits and are basically what you're going to do with a thread sleep is you're always going to have to pay that bill. You're building in a penalty, a timing penalty to your test because you either don't want to or don't know how or don't understand the system enough to hook into app state. When you hook into app state, you don't have to penalize your tests.
System. In fact, in my preferred approach, these tests will never be wrong because of changes to the system under test. They may fail when the plumbing breaks, but then we can fix the plumbing. But they're only wrong if the users no longer want the thing that the tests assert. How does all this relate to end-to-end testing? Well, if we drive the behavior via system A here, then we need to know how to get system A into the correct state so that it will send the information that we're really interested in to our system. That's not likely to be an easier thing than just sending the information that we're really interested in direct to system B. So it's not very likely that our test will be simpler. I'm probably cheating a little bit here because with my preferred approach, you can usually hide a lot of this complexity so that the test cases themselves may still be concise, but the test infrastructure and test data will inevitably be more complex.
Yes, that's the problem. That's where I'm not a fan of BDD frameworks, because they sell themselves as uncomplex or uncomplicated. But they are very complex generally, or let's say just as complex as any other code-driven framework, but they want to pretend to not be a code-driven framework. Again, using an example like SpecFlow, using an example like Gherkin and Cucumber or Robot Framework. They will hide their complexity behind human readable language, but ultimately you're still going to need a technical person to write all of your actual code in the backend to do the things you need to do, unless your app is really simple. Then getting it to scale properly, when you have that extra layer that obfuscates out the technical part of it from that first layer, from a high level view that project managers and CIOs and CTOs love to see, and that's why they will push BDD, because it's human readable. I can understand. We could take the requirements and turn them into a test. That's great. But still, somebody has to write code in fix code to support that test code. Excuse me. Someone has to write test code to support those keywords. Usually it's written in something called Gherkin, so that it all works. It's not magic. You don't get it for free. Even with the UI based GUI tools, now there's a good chance you'll get roped into some sort of service where they're going to be writing that stuff. And then you don't have access a lot of times to the guts of those keywords. You're completely at their whim, or at the very least, you're writing Robot Framework. You're writing like Cucumber, SpecFlow. You at least have control of the guts of the underlying code, because ultimately those keywords are just function calls. It's what they are. They're function calls. They're just harder to write. They usually have a more complicated syntax. Try to write a Cucumber test and you'll see what I'm talking about. One that's parameterized, as in it can take some sort of argument, compared to just writing a function. I feel like my camera is really far behind my mouth and my voice, but that's okay.
And so harder to maintain. Our tests won't be as accurate because we've lost the ability to precisely control the state that system B is in. The only way that we can do that is by guessing where our system ends up after the external system talks to it, or breaking encapsulation by digging in and looking at or changing the private state. I see this second failure a lot. It's a really bad idea because it immediately couples the tests to the system under test, so they break all the time and are much more difficult to maintain. If we're testing end-to-end in this way, our tests are unlikely to be understandable either, because when we're writing them, we're probably worrying about interacting with System A or System C instead of thinking about exactly what it is that we want to learn from our system. Again, you could probably make understandable tests with my preferred DSL-based approach, but you probably won't. Finally, these tests are definitely not durable. Simply by the act of adding systems A and C into the mix here, we've increased the amount of places where stuff can go wrong. These sorts of end-to-end tests are notoriously difficult to maintain as in a stable, reliable suite. What we'd really like instead is to deploy our system so that as far as it's concerned, it's in production. Same infrastructure, same configuration as far as makes sense, and using the same deployment mechanisms. Then we'd like to connect it to a test rig of some kind, test infrastructure that allows us under test control to put our system under test into exactly the state that we'd like it to be in.
Yeah, but now you're building this test rig you get into a weird place where you start doing things like page objects, where you start to code your own understanding. It's like you're trying to create like this parallel version of the app in your harness. I feel like there's a gray area in between, again, using something like Playwright or Cypress, where you don't have to do this. You deploy the real things, then you mock out or intercept the parts that you need to be aware of and hook into app state. This, to me, looks like you could get into, you're having to maintain now almost the real app, and now you have to maintain like your understanding of the other parts of the app, the other integrations. And that gets weird, rather than just having the real thing there and then just obfuscating out just pieces of it or intercepting parts of it and hooking it to its app state to know where it's at. Or again, let's say another approach to this that I like to do is if service A has an API and service C, back to his diagram, I would rather have my test always check for those things and always set them up headlessly before, in a before method, and prep the environment, or post, like maybe clean up and then set up for the next test. Because again, then a lot of this weird stuff, and I don't have experience with something like this, this feels more complicated than just using a tool like the ones that I mentioned and being hooked into app state and intercepting and stubbing and mocking parts of it out, and also using hopefully a robust API to get the environment, the test environment, in the state that you need it to be. Again, does this user exist? Check for them. No, we need to create them and have a little bit of guts in the back. That's going to kind of, and maybe that's kind of what he's talking about here, but it looks like he's taking system A and B out. And again, now you're setting up like mock servers and you're doing some, in my opinion, some weirder stuff that I just think is more fragile. Your tests might be more robust, but now you've built this weird infrastructure around your tests in system B that is just as fragile and is extra work. But maybe this is way easier than I think.
Communicating through its natural existing exposed interfaces. Then we invoke the behavior that we're interested in testing, and we'll collect the outputs from our system via its natural outputs and make assertions on them. So these kind of...
It's kind of what we do with most modern frameworks. You're doing that very thing. You're arranging. The way I would arrange is probably interacting with the real service, additional services, if it's, again, system A and system C. And, well, the thing though is that verifiable output, that's probably where I would also take system C out, is I'm going to just do assertions. I may capture, like for example, if I'm doing like a authentication test and I want to do it headlessly, I may capture, say, the response from the authentication endpoint and just make sure, interrogate the cookie and say, yep, they gave me the right kind of cookie. I'll be able to interact with web pages. So that might be kind of a similar aspect to this, right? Or I may interrogate if it's a PDF service and it's streaming me a PDF, I may interrogate that PDF a little bit instead of going maybe to the page that's supposed to show the PDF. So apples and oranges, maybe? I'm not sure.
Tests are black box tests that run through the exposed interfaces to our system, but where the tests fake all necessary inputs and collect resulting outputs. We replace system A and system C with fake versions of them so that we can more accurately control our system under.
Yeah, but then you're maintaining like a mock API of both. This is where I feel like it's so much extra work than just deploying the real thing and then mocking and stubbing the parts that you need to control. I don't know. I feel like that's less work, in my opinion, and it's less infrastructure to have to maintain.
The test. So I guess these tests are end-to-end as far as our system is concerned, but not as far as systems that are outside of our control and responsibility to test. So one of the important decisions to make when automating your testing is to decide what constitutes our system. What part of the system are we responsible for and responsible for testing?
That does get tricky, especially for SDETs. We're trying to figure out where the risk is and the seams are. Where does the buck stop? One good example of this that I've had issues with clients, with past jobs, is clicking links. What I mean by this is when you click a raw, plain href, the point of the click and then the site actually, well, the redirect essentially of you clicking a link, going to a page that's there in a plain href that you could check. It's right there in the code. It's not some button that fires JavaScript and does something. It's literally just, here's an href. I go to that page. Where that page is there exists. Doesn't matter on anything else that I've done, let's say. At the point where you have a test that clicks on that link that has the href and then goes to that page and then says, yep, that page, this is where we are. You're now testing Chrome. You're testing the browser's ability to redirect to an href that it's been provided. So a better test might be, do these hrefs maybe match our standards or match the pages we expect? Did someone not accidentally put the wrong href in here? Now, there are times that buttons may generate, or you need to have previous activities that where you go to that page, it's going to look different to you. But again, you could probably mock that out. You could just go directly to that page with, say, a particular cart or a particular app state. You could mock that app state out. But again, if you really want to figure out where that buck stops, where's the buck stop? Do you want to test Chrome for Google? Do you want to test Firefox for the Firefox team? No. If it's a plain href, a good test is to say, when I go to this page, I expect these type of hrefs to be there. Usually do like a contains. And then generally these buttons and everything are set up correctly and the user is going to be able to do and get to what they need to get to and do what they're going to do. So I agree here. You got to figure out where that buck stops. Where are our responsibilities? Where's the responsibility of another team? We don't want to test their app for them. But even though we rely on them, I agree with this approach of now we're going to mock the optimal state. But again, you can control the mocks and the stubs and stuff on your side if you're using the right tools and approaches, and you could still interact with the real system.
Continuous delivery helps with this decision. My preferred quick way to describe continuous delivery is that we work so that our software is always in a releasable state. So what does it take to decide if our software is releasable? That's obviously specific to each system. But one thing is for sure. If at the end of evaluating your change, you or someone else has more testing to do before release, then it's not releasable. So the standard here is that if your deployment pipeline says all is good, you should be happy to release into production without any more work. So the scope of a deployment pipeline is a releasable unit of software, whatever that means for your system or subsystem. And acceptance tests are by definition designed to determine if your software is ready to release.
Yes, build acceptance. This is the pitfall that a lot of teams fall into that don't understand what it means to have continuous integration, continuous delivery. Completely agree here. Completely agree. This is a pitfall. They don't understand. They'll have the pipeline, they'll have acceptance tests, there's still more that has to happen. And that's not continuous integration, that's not continuous delivery, it's something else. Some QA person still has to go like this. And that means you don't trust your tests in your pipeline. You need to find a way to trust them and still have valuable things for testing people to do, because there is valuable things like exploratory testing, which leads to new automated tests. They find things that are wrong. Being a customer advocate, shifting is far left. Could go on, but.
So the acceptance tests test a releasable unit of software too. They confirm that everything in the deployment pipeline works as expected.
But that's hard to do. Writing tests well, the way that Dave's talking about here, is harder to do than the traditional way that most teams write tests. To write that build acceptance is much, much harder to do. And that's why no one does it. People just write a bunch of tests and they fire, or good example, performance testing. A lot of people don't actually understand performance testing. They just fire a bunch of requests and that's performance. Well, they'll usually say load. And they don't realize it's completely different. And there's like subsets of performance testing. It's the same thing here. is we're just going to write a bunch of tests, cover all our requirements, and they're going to be super fragile, and we don't trust them enough to validate our build. And so some human still has to be in the pipeline. And again, it gets deployed to maybe some stage or dev environment, but we wouldn't dare push it out to prod yet. It could be broken. And that's because we don't trust those tests. We don't trust our app. There's a breakdown in trust.
So these tests are kind of end-to-end tests, but only for our software, not for anything else. What this means is that we can test every aspect of our software, including things like its deployment, configuration, and changes to the infrastructure on which it depends, but without testing any software that's outside of our direct control. To do this, we fake interactions under test control between our software and systems that it collaborates with. This gives us what I call measurement points for our system, places where we can provide inputs and collect outputs to make our tests realistic, but also as simple as we can get for our system. These may still be complex tests, but they will be focused only on the system that we are building.
Right, and I think that's the right approach, and I would agree with that. You want it to be as focused as possible. You don't want to test other systems that you rely on. And I know I'm just beating the dead horse, banging the same drum. I feel like you don't have to go as far as to fully mock out both those. Unless, again, deeper in the stack maybe, you have those. But those could be run, if you're doing full-blown unit testing, those are run locally too, where this is a little different. We deploy it, we run those tests, we mock out the other parts, yada yada.
You may be worrying about the interactions at these points. And you're right, these are why people don't feel safe without end-to-end tests. But if we have thoroughly tested our system with our close to the edges acceptance tests, then all we're really interested in about these conversations now is, does A talk to us in the way that we expect, and can we talk to C as we expect? When we think of these tests like that, then we don't need lots of complex testing at these points. We need more focused tests targeted at verifying these interfaces. These more focused tests are actually better at verifying these interfaces too, than just throwing usually boring cases through the whole end-to-end system. This approach is something that I've mentioned before, contract testing. So we get to more thoroughly test our system, and we get a better, more targeted validation of these interface points.
Yeah, in that case, what I've seen in the past with contract testing is you're sort of testing out that your system is capable of serving anyone outside of it. So in the case of System A is going to make sure it can fulfill all its contracts that would generally do for System B. And then System B is going to do the same for C, and C is going to do the same for up and downstream. Where essentially you're making sure, can we fulfill the needs that we know? Your tests almost act as like your first consumer of that service or that system, and do the things against that system that the other systems that rely on it would do. Which maybe sounds obvious, isn't that what testing is? But it isn't always that way, right? Again, if we are doing a full-blown end-to-end test with no mock stub spy, no intercepting, it is going to be super fragile. I agree, and you're going to have problems. I think contract testing, I would agree to the broad idea of contract testing. I would disagree with maybe the implementation of building this big testing harness around each service.
There is a step further that we can take. If we write our assumptions of how we will interact with systems A and C in the form of contract tests, we can give them to the teams A and C. They can now run our tests in their deployment pipelines. Now, if they make a change that breaks our assumptions, it'll cause our tests to fail. And they have to decide what to do next. Fix their code so it doesn't break our test, or come and talk to us about our need to change our assumptions and/or our contract test. This approach is sometimes called user contract testing. The places where this approach breaks down is where the interfaces between the external systems and our system can't really be trusted, which is common in big ball of mud systems. But the real answer to
I would call that monolithic systems, but he likes to use big ball of mud. But yeah, talking about monolithic systems. generally if you work for a company that's been around for a long time, there's some monolithic systems sitting around that are too big to fail and too big to remove without full greenfield rewriting of the system most of the time. It's crucial to the business, or it's crucial to another business, or crucial to the clients that you do business with. And so you have this monolithic system you have to maintain and try to test.
To this problem is to stabilize control at these interfaces. As I've said before, these sorts of places in code are more important than other places, in the sense that they will propagate problems between teams when you get them wrong. And those sorts of problems are really quite a lot more difficult to deal with when building software with lots of teams. Once we have this idea of end-to-end for our software, but not including everyone else's, we can do some smart things with our test infrastructure. Effectively, as I said at the start, building a sophisticated test rig that our software kind of plugs into and allows us to more easily and with high levels of precision put it into whatever state we need it to be in for this test.
I'd like to understand what he means by test rig, because yet again, I'm very skeptical of this idea that you build all this specialized infrastructure just to test. And again, that's where you get into weird stuff. I've always been very leery and skeptical of page object model because it kind of does the same thing. You're trying to replicate your idea of what the system is like again, the state of the web pages, rather than hooking into that state and trying to understand and still trying to accomplish what the user is going to try to accomplish. This is where I'm skeptical. Maybe if I was able to see how this was built out, I would be less skeptical. But my examples of this again are, you're going to set up like a mock service. You're going to deploy your real service in isolation and set up your mocks, right? Then, these two mocks, again, if we're talking about system A, system B, system C, those two mocks are always going to respond in the best way or the worst way if we purposely want to see, like he's the example. Now, again, you're having to maintain two mock servers that are going to hopefully act the way you want, or you're going to have to try to mimic what you think those two systems are going to be like, rather than just like spying on the real systems using other frameworks. Just again, my opinion, I feel like it's hard. It's more work to do what he's saying, but that's from the perspective of I have yet to work at a place that does it this way. This might be far superior to even my approach as an estet. I want to give him the opportunity. Dave knows what he's talking about, but my tummy's grumbling. I'm sorry if you can hear it. I'll edit that out in the YouTube video anyways. And the snapping of my knees because I did some manual labor on Saturday and used a jackhammer for a while. And my knees keep cracking because of it, and I'm at my standing desk. The beauty of editing, no one will know unless some weird, sad soul watches the live stream later or something like that. But
when we built the LMAX financial exchange, this was exactly how we organized our acceptance testing. Our system integrated with 25 to 30 different external third-party systems. For each, we faked it when acceptance testing. So we could do things like this. In this example, the approve account call on accounts is priming our test infrastructure, our stub that represents an external third-party system. When our system under test makes a call to this external third-party system for, in this case, know your customer checking or similar, for a named account, we have predefined the response that we'd like it to give. So we're certain that the account will be approved.
Okay, hold on. I want to go back and look at this code because there's warning bells. There's warning bells going off. So a couple of things that I personally don't like and I feel can make your tests harder to understand, something he's doing here. One thing he's doing is he has these objects. Well, first let me start with the things I like. I'll do that. Let's start on the positive side. One thing I like that he's doing that I would highly suggest people try to do look at the name of his test method. Should allow invoice submission for approved accounts. The awesome thing about that naming, and I would say I give him a 10 out of 10 for that naming, is that when this test fails on assertion, if the assertion fails, you know what's wrong. Now, if it throws an exception, that's just like anything else. You've got to dig in and figure out why this test failed. The beauty of this naming is, again, when this fails, you know that it did not allow invoice submission for approved accounts because your assertion failed and you asserted on that. Beautiful. I do like that he obfuscates out some of his test logic to these methods and these objects. What I don't like is obfuscating or hiding out your assertions. When you put assertions in methods, you now have created an additional layer to have to dig down to find out what did go wrong when there is a failure, maybe with multiple assertions. That can make it really hard to troubleshoot when you're looking at a like a log file off of a failed testing suite. So personally for me, if I can help it, I'm always going to put those assertions at the test level so that when it fails, I don't have to dig down into some method written to assert. I do like, as far as I can tell, he submits the invoice and then he confirms it. He at least didn't put the assertion in the submit invoice method. Because again, submit invoice should be sort of, you might be attempting to do that thing, knowing completely that it will fail. And in fact, you expect it to fail. So your assertion may expect failure. If you bundle in your assertion into submit invoice, you're always doing happy path then. Or if it throws, yeah, there's lots of weird stuff there. So that's where I'm going to say I don't really like hiding assertions down in methods like that. But it's really just personal preference at that point. I just feel like it's much clearer when the thing fails. But he has a great naming convention. So again, if his assertions fail, he knows exactly why they fail. This is looking page objecty, POM. So again, I'm always really skeptical of things like this where you're maintaining all these objects. You're maintaining all this, like, again, additional logic. You're building, I'm trying to build like almost a mirror of the system behavior, and things just they tend to get weird and they tend to be difficult to scale, and it tends to be hard to bring new people in. Say like, oh, well, we have all these objects that we built that mirror the objects in the system, and we have to maintain these alongside the real objects that are in the other app code and the other services. Again, I'm personally not a fan, personally never seen it scale. Just my 2 cents.
Response that we'd like it to give. So we're certain that the account will be approved. Here's the opposite case where we want to simulate a rejection. None of this is really very complicated, but
putting a try catch in a test, interesting to me. Well, I'm assuming this test is not a unit test because won't you have a failed assertion anyways when you run these tests? Why put a try catch? It could be, again, baby SDET doesn't understand how developers write tests. But that seems weird to me. Like, if I have an assertion, why should I catch? Why should I try something and then catch it? Isn't that the whole point of like using a test harness, is that we don't have to, it's technically try catching. It's going to try something and then we assert on it. Unless we think that that assertion is going to throw an error that isn't going to be handled by the testing framework or harness. This is weird to me too. I really like the naming convention, should reject invoice submission for rejected accounts. If your assertion's written well, I don't think you should have to do a try catch. This is odd to me. But again, I'm coming from the perspective of higher up in the stack. Lowest I usually go for clients and teams is component level, and I've never had to write a try catch in a component test. So maybe this test is more of like a unit, what I would consider a unit test, but I even consider component tests unit tests. You do a lot of mocking and stubbing. I like that as an assertion though. I think he's doing some arrangement here. There's certain parts of this that are just weird to me, and it could just be my perspective as a tester.
From the perspective of our system under test, it doesn't know that this is all faked. This approach also means that even lengthy, complex, long-running interactions with external systems can be simulated in very short time frames, microseconds sometimes.
Which you can do with Playwright Cypress. I should put like a dead horse graphic up of me hitting a horse. I feel like this is a little bit strawman then. I'm starting to feel like this could be a little bit strawman because it's portraying end-to-end testing as like this or this and that's it. It's too black and white when the tools and the approaches you can take let you kind of stand in this middle ground and write tests that use the real systems but mock out the parts and stub and spy the parts that you need to work the way you need, or the other parts that you just want to run the way they run and you're okay having some dependency on them, you can leave them be. Or you can generate, again, I need to create a user. Why don't I use the API and generate that user before my test runs? It's in the before method. If it fails, the whole test just, takes, just completely explodes, and that's fine. Now we know there was some deeper issue. But again, if I needed that user, but I didn't care about testing, and now I had a way of mocking and stubbing, I'd definitely mock and stub that user. But there's probably other tests, though, that need me to run fully end-to-end through that system to make sure that the user is able to do the thing that they need to do in the system. And I'm going to have some of those tests, just flat out. If I push a user guide, or my org pushes out a user guide to our user base, I want 100% coverage. It may not be all automated coverage. It may be part manual, part automated, but I'd want 100% coverage to say, yes, if my boss comes to me and says, this user guide we just pushed out, is it fully tested? Do we know all these flows work within reason? If I can't say yes, or, well, we have 50% because we have all these things isolated in these pieces, that's not, you have to be able to say, yes, we are able to fully, 80% automated, 20% manual, or some number there to give the, the product owner, or the CTO, or whoever confidence. You need to be able to have confidence in the user guide that they sent out. But that's probably like a whole nother video. That's collaboration, with like product owners, where they're going to tell you, here's the new user guide. Okay, I want to make sure I cover that. Maybe I tag tests as user guide tests along with other tags. And when we push a new user guide out, just before we do, you review it. You have a story in the backlog to update it. You run those, update and then run those tests. The user guide's good. Within reason. Anything could go wrong, right? Anything could go wrong.
So, as well as being more deterministic, these tests are also a lot faster than if we had a real system to talk to here. We did this at LMAX for all the time that I was there. I'm pretty sure that they're still doing it now, many years later. We ran our own contract tests against each endpoint, usually the endpoint's beta test site. And during the 5 or so years that I was there, we never had a production incident caused by a failure of our interactions with these external systems. We sometimes had contract tests that would fail against their beta site, and we'd change our integration with it appropriately. Once we understood the change, we'd do this by first changing our simulation in our tests. This is a much more controlled strategy for very thorough, very detailed acceptance testing, and is a lot more effective and a lot faster than the end-to-end alternative. Thank you very much for watching.
Okay, well, let me leave that up. So in case you guys want to go follow Dave on, now it's X. Go follow Dave on X. Go follow Dave on LinkedIn. Well worth the time. I'm going to say that I agree to disagree with a lot of aspects of this video. I appreciate the idea of breaking your testing up into more atomic chunks, making them concise, durable, while also facing the fact that your tests are going to deprecate, they are going to wear out, facing the fact that there's going to be times that you still need to test your app end to end. There's going to be things you want to make sure are good. Where the risk is too high, let's say it's compliance. Let's say you're doing government contract work, there's going to be stuff they want to see that you're doing specifically. And following certain regulations, it's just, and I get to, Dave's trying to bring general good principles and process to many different teams. I think he's fair with it. I would just disagree about the approach. I feel like almost in most circumstances, you can test with real system A, B, and C. And again, mock out the parts that you need. Mock, stub, spy. The frameworks give it to you. It's very easy. In fact, that's something I probably should demonstrate in the future. In fact, I think I have. I think I've demonstrated in this past while we've worked on tests. Is that something like Cypress, while you're running your tests, it's going to show you every single call that's being made that you wouldn't normally see in like your network tab in your browser. If you use developer tools and you go to network tab, you're going to see all those calls that happen. So, and you can literally copy those calls. You can paste them in, or basically have them, what I'm going to consider a paste, or essentially you can click on it and it goes to your console, also in your developer tools, and see what that call is constructed of and easily copy and paste it into your test code. It's been a while since I've been into Playwright. I want to spend more time. In fact, I want to do a video in the future where it's Playwright, the Playwright recorder. I believe that's what it's called, against the new Selenium IDE. That's a future video coming up. But yeah, overall, I agree. I agree to disagree with Dave here. And coming from, I've only been doing this for 13 years or so approximately. I believe Dave's been doing this a lot longer than me. Dave's perspective also is more developer focused. My perspective is always tester focused. I feel like his approach is great, but his approach would be really hard to do post, let's say you're 3 years or a year even in development. I think it'd be really hard then to inject this, where the method I'm talking about, you could come pretty late. It's going to be more painful, but you could come pretty late in the process. Start a Playwright or Cypress framework and start intercepting calls, start mocking and stubbing out the calls, and start building that out. And you wouldn't have to rely on any infrastructure like that. You're just going to be writing tests and then using the existing system logic and then kind of capturing that logic, right? And your test will fail if that call doesn't happen anymore, and you're not able to mock it and stub it out. So you're going to know right away when that system changes. I think there's merit to what he's describing here. I think there most definitely is. I just feel like, again, there is alternative approaches, in my opinion, from my standpoint, coming from a testing standpoint. I think you can shift very far left, and you can write a lot of these tests very early, so you're not having to wait and operating basically as waterfall Kanban. Though the rest of your team is supposedly Scrum, you're waiting as the tester, as the QA analyst, QA engineer, SDET, for that thing to get deployed. There's ways to write those tests ahead of time. I like tests. I like Dave's testing format, I guess you could say. I like the way he names his tests. It's clearly following arrange, act, assert, but I don't like that he's building all this extra infrastructure just to be able to test. I don't think you have to do if you use the right tools and you use a different type of test design. So yeah, that is it for today. Hopefully this is useful and enjoyable for people watching this out on other platforms like YouTube and anywhere else I decide to put this, like Bookface. I would highly suggest, if you're watching this later on other platforms, you'd be helping me out by clicking the like button. You'd be helping me out by subscribing, and then you'll be notified when I go live or post a new video. I don't have a lot of videos yet, but I want to be able to edit these down. I had a video recently that I was editing and you could hear my kids in the background screaming. So I went through about half the video, and now my kids are screaming. I gotta figure out a better solution for where I record, and that's just on me, or where I there's a live stream that I was trying to cut down. And yeah, clicking the subscribe button helps me a lot. If you want to come over onto Twitch and follow me on Twitch, I try to go live every weekday if I can, around noon US time, unless I have a meeting. I've been doing software testing for about 13 years. I run my own consulting firm called Level Up QA. But again, I'm Boomer Tester. Hope this is enjoyable, and I appreciate you stopping by and hanging out. Have a great day.